So we've seen one special triangle, that was the 30, 60, 90. The other special triangle that we're interested in is called the right isosceles, and a right isosceles triangle has a right angle, and isosceles means that the two legs of the triangle are the same length. Okay, these two sides have to be the same length to be isosceles. And so let the length of this side be 1, and therefore the length of this side is also 1. And also in a right isosceles triangle, if these two sides are the same length, then these two angles also have to be equal. Right? So the length of the side opposite of this angle is the same length of the side opposite this angle. That means the angles also have to be equal. And this is only going to work for a right triangle. And so since this angle is 90 and all three angles have to add up to 180, and these two are equal, they must be 45 degrees. Because 45 plus 45 is 90, plus 90 more is 180. And so we have a right triangle. We know the length of two of the sides. We can find the length of the hypotenuse here. The hypotenuse, C, will be equal to the square root of a squared plus b squared. And so I'll use my standard labeling. This will be angle A, B, and C. And this is side C, the hypotenuse. And so C will be equal to the square root of 1 squared plus 1 squared. And so 1 squared is 1, plus 1 squared is 1, and 1 plus 1 is 2. The length of side C has to be the square root of 2. And so this will be the square root of 2. And so now let's look at the trigonometric functions for 45 degrees. For 45 degrees, the sine will be the opposite over the hypotenuse, which is 1 over the square root of 2. And again, I don't want a radical in the denominator, so I multiply the numerator and denominator by that radical. In the numerator, I'll get radical 2. And in the denominator, the radical cancels, we get 2. And so the cosine of 45 degrees, well, the cosine, the adjacent over the hypotenuse, is 1 over radical 2. And they are equal. They are the same. The sine and the cosine for 45 degrees are the same. And that's because the opposite and the adjacent sides are equal. And so this, if I multiply numerator and denominator by radical 2, we will get radical 2 over 2, just like we did here. Now the tangent of 45 degrees is going to be the opposite over the adjacent, which is 1 over 1, which is just 1. And the cotangent of 45 degrees is the adjacent over the opposite, so again 1 over 1, which is 1. The secant of 45 degrees will be the reciprocal of the cosine, and so the reciprocal of the cosine is going to be radical 2 over 1, which is just radical 2, and the cosecant of 45 degrees will be the reciprocal of the sine of 45 degrees. And so again, 1 over radical 2, its reciprocal is radical 2 over 1, which is just radical 2. And so these are the 6 trigonometric functions, or ratios, for 45 degrees. And we have these, and again, in an exact value, because we have this special triangle where we can prove that the ratios of the sides are what they are based on what I've just done here.